Hi, and welcome back to the AITX Community Podcast, the show where we go deep with some of the most interesting AI engineers, entrepreneurs, researchers, and operators across the state of Texas. I'm your host, Jake O'Shea. We specifically focus on Texas because we believe the engineering community here is seriously underrated. People here are solving complex technical challenges and building incredible products, and our hope is that this podcast helps shine a light on those stories and shares them with the rest of the world. Today's guest is Scott Wilcox, a true Austin OG. He's someone who's been here from the city's evolution from a scrappy, creative town full of weird people to now a world-class technology and startup hub. Yes, still filled with lots of weird people. Scott was the first technical hire at South by Southwest, one of the largest technology and creative conferences on the planet. Over his 25 years there, he grew into the role of CTO, helping shape South by Southwest into a global platform that drives a Super Bowl's worth of economic activity into Austin each year. While at South by, he led the organization's digital transformation, built their platform from scratch, and guided their technology strategy through eras of massive change, both in culture and in tech. After South by Southwest, Scott went on to start several of his own technology businesses. He's currently building Janix AI and utilizing new AI infrastructure and data tools such as MCP to reimagine autonomous systems and capabilities. Scott's story is quintessentially Austin. It's inventive, community-driven, unreasonably optimistic, and yes, a little weird. But that's what made my conversation with him so much fun. Whether you're an engineer, a founder, or just someone who's curious about how creativity and technology collide, this one's for you, and I'm really excited to share Scott's story. So, without further ado, please enjoy this deep, wide-ranging conversation with Scott Wilcox. And we're live. Scott, thank you for joining me today.
Wow, thanks for having me.
Yeah. So I'd like to get started by talking a little bit about your personal background and kind of what first got you interested in engineering or technology. So tell me a little bit, like, how'd you grow up? What first kind of sparked that interest? And
Sure, I'd be happy to. So I grew up in rural New York State. Small town, like one town schoolhouse, kind of small, but they had a computer lab. And so as I was like going in, like through second grade and third grade, they're like, oh, there's this new computer, right? We've got, right? And so I got some time on that and I started to be able to, I built my first program. I was like, this is amazing.
was this
Right?
like, not to date you, but was this like punch card days or?
No, this is like Apple II,
Okay.
right? Apple II, Apple II Plus, Apple IIc, IBM X86, at the 486, the 586. But like my first computers with Timex Sinclair, right? And it was like a $150 computer and it came with, you used a tape deck and audio tape and you saved the programs on audio tape, right? And so like I could basically take that Timex Sinclair and I could write programs for it or I could download other programs. And what it was is like 3 minutes of audio stored on that tape transmitting the program to the Timex Sinclair.
So like
right?
the audio signals get translated into binary code and then
Yeah,
turn
exactly,
into a program.
right. And my
That's
friends had
crazy.
like, Commodore 64 and like the TI. And so really, really grew up at the age of like the personal computer was suddenly affordable for middle class or upper, middle class families, right? Or upper middle class families probably, but also they were showing up like in schools, like, oh, we have a computer lab. Here's an Apple II, right? And that's it, right? So immediately my imagination was captivated. And it was really exciting. And I got into doing some programming and did some competitions all before the age of 10. And so I was familiar with it. And then through like, high school and like, I really kind of stepped up the game, started like really building my own computers. And it was just this limitless possibility of what you could do with it that really sparked my imagination. And so that I think got the bug for engineering and building systems.
Cool. So grew up playing with computers, building them yourself eventually. Did you then go study computer science or engineering in college?
No, I didn't at all. I did not study anything technical in college. So
What was kind of the impetus for studying something else?
I was like, okay, I like computers and math and science. It's all pretty cool. And then I was like, but I really like stories and I really like understanding literature. And I felt like I really wanted to be more rounded, essentially. Sort of like my goal at the time was to be, as funny as it sounds, but like a Renaissance man, right? To be able to kind of do all of these things and to have this breadth. And so I went and studied that, and then I was producing music. I was playing in bands, and I was producing some films and some theater. And so when I got out of college, I kind of found the happy balance between the two with South by Southwest.
Nice. So that's kind of a good natural transition. Sounds like growing up, lots of interest in kind of building and engineering, but also this kind of other interest in like art and culture, et cetera. Studied that in school. What was your first job out of school? Did you go straight to South by, or?
Yeah, my first job, aside from waiting tables, sort of like the summer after college, my first job was South by Southwest.
Oh, wow. Okay. So tell the story of kind of how you fell into that opportunity.
Yeah.
Like, I guess also what brought you to Texas in the first place?
So we were in upstate New York. My dad came home one day and he said, "We're moving to Houston. I'm working on the space station."
That's pretty cool.
We said, "We're doing what?" He's like, "I have an opportunity to work on the space station and all the training with my company, and they're going to give me a raise, and we're going to go live near the Johnson Space Center so that we can, build the best training devices we can for the astronauts." So that took me to Houston, right outside of the Johnson Space Center, right? And so I had several friends that were astronauts, right? Like flying shuttle missions, doing Cape Canaveral, so really, I think that also really sparked a lot, like being in that sort of high-tech community, like really pioneering on space. There was a lot of engineers. There's a lot of kids of engineers. And so there was lots of people to geek out with.
Okay, right on.
And that took me to Austin. And then for college, I decided to travel as far away as I could from Houston. At the time, I was
classic college
18 years old. I'm like, yeah, I'm ready for the world. But I went to Kenyon College and studied English literature, psychology, and sociology, and then spent my junior year at Exeter University studying British literature. And then when I graduated, I kind of moved back, and I always knew like Austin had a sweet spot because having grown up in Houston, we did like UIL tournaments up here.
Yeah.
And I saw Fugazi at Liberty Lunch. When I was up here on a school trip, and I was like, I'm moving to Austin when I can, right? And so when I got out of college, I had some buddies that were like, hey, we're getting a house up in Austin. I was like, yeah, that sounds great. And then when I got here, I was like, okay, I've been producing concerts at my college, I've been playing in band, and I've been, doing some short film stuff. And I was like, who's doing things like that?
Awesome.
And
so you discovered South by Southwest?
I discovered South by Southwest.
What was South by like back then when you discovered it? Because it's
Yeah,
obviously
really
evolved and changed a ton.
Yeah. So at the time it was sort of run out of a house on 40th Street in Hyde Park area. And it was like a dozen people maybe who were all like working on, bringing this music festival, and particularly for sort of up and coming bands, right? And they had just started the multimedia event the year before, and also the film event the year before.
So how old was it at that point?
My first year producing the event, full-time on staff, was 1996, so 10 years.
Okay. And it had just launched this kind of multimedia.
Yeah, right. And they had just launched that in 1994, kind of based on CD-ROMs and multimedia, and kind of brought this idea in, and had just kind of getting that going. And the same on the film side, right? Like deep interest in the co-founders on film, both Nick Barbaro and Louis Black, kind of roots in the film industry, right? And so they're like, hey, our thesis is convergence. Is that music and film and like whatever tech is gonna be, it's like all gonna kind of like come together and complement it. And that really resonated with my like desire for a well-rounded liberal arts education and And I thought to myself, okay, what better thing to do than to bring all these thought leaders together to talk about ideas and to create a space where creative people can share and advance their goals together. And I was like, I'm all in. And so I literally just kept showing up until they're like, okay, I guess you can work here.
I'm imagining like young hippie Scott with long hair.
Yeah, yeah.
Like, what's up, man? It's all convergent.
Exactly, right? And so when I got there was like a few computers and a CompuServe account, and like every database was on its own computer, right? Like there was no sharing of sales and bookings information. There was no common contact database.
Probably didn't even buy tickets online back then. You would literally like show up.
You didn't. Well, my first job was opening the mail to take the registration forms and the checks out, and then to also grab them from the fax machine. Okay. And so I was like, this is not a great first job. Like I have to type in all this stuff. So when the web was happening, and I started thinking, how can I automate my job? I literally was like, how can I automate what I'm doing right now so I can do some other more important things than typing these things in? And so we had like a 3-page website at the time outside of like Monster Bit Media. It was like a local kind of web hosting thing. And then we were using, there was a local ISP that was also sort of like early on. And so immediately we started looking at like, what are the opportunities? What if we bring the website in-house? And I was trying to make a new job for myself because I didn't want to type in this stuff anymore. Yeah. So I started looking at like the databases and say, okay, how do we bring all the database designs together? How do we like share information between sales and booking? And how do we get a common set of contacts? And when a band applies, like maybe they're connected to somebody. How do we start to leverage that intelligence? And so I immediately was like, well, this is great. It's arts and it's creative, but now I can put my engineering mind to work. Yeah. And so started looking at open source software, started writing code,
So had you just kept that like writing code muscle sharp through college? Like kind of doing it on the side as a hobby, or did you kind of have to relearn?
No.
You just knew like I'm interested in computers, like I can figure out how to.
I had done enough. It's like this sort of thing. Like if you learn to play guitar, you learn to ride a bike. Like even if you haven't done that in like 3 or 4 years, it kind of like quickly comes back. Yeah. But it was totally different. It was like, okay, I'm writing Perl script and doing like CGI bin stuff based on like early web tech, right? And like the first video I produced at South by Southwest for online video was like 1.5 inches or 2 inches by like 1 inch, right? And it was like really awesome. Like, oh, we've got MPEG, like sharing these things, right? And so I just kept looking at every opportunity with this sort of like Web 1.0. What are the opportunities to advance our cause, to create this world-class event with creative people from around the world that can share ideas and who are also interested in technology? So that's a great setup to innovate against, and it kept me really busy for a long time.
Yeah, so you kind of create this role for yourself at South by doing like website stuff. How did that kind of evolve over time as the festival itself and the organization was growing?
Yeah, that's a great question. So, if you think about this, like immediately it was like, okay, we've got this database that works. People can register online. They can look people up online, right? Like all of the stuff like can be sold that way. What about like all these CDs we're getting in from these thousands of bands, right? And so,
and this was like for them to apply to play.
Yeah, and we're like, okay, well, great, yeah. So let's create a system where they could apply to play, right? And then also let's start sharing their MP3s, right? And also let's ask the filmmakers permission to send us like a trailer, and we'll put the trailers online, right? And so I did that, and as I had this website, I realized I couldn't really get everybody in the company to write for the website, or really anybody. So I created the content group that translated the vague ideas or from across the organization into actually tangible stuff that we could post. And so then we started blogging on the website, and we started getting that engagement. And that was really key to interactive, for instance, growing. So, eventually like, multimedia turned into interactive. And as interactive started sharing their thoughts, like that really helped us capitalize on the social media, right? And so there's these various phases, like leading up with the .com 1.1, it was like suddenly everybody had a .com, and we were very happy to have them all come to South by Southwest and like have their booth in the trade show and stuff.
And really quick, just for folks that don't understand kind of the way South by is structured, because it's kind of unique. It's really, I don't know how many today, but 3 or 4 separate kind of festivals merged into this 10-day long, like weekend through weekend experience, right?
Yeah.
So you've got music, which is kind of how it all started. Then early on, they added in film. They added in
what became interactive.
What became interactive, which was really just multimedia and kind of getting brands involved.
Well, yeah. Well, once the web, like the early blogging, we made a community for people like that, right? And cultivated that, right? And that turned into interactive, and then
interactive is like the panels,
right? Yeah. And then it expanded kind of even more broadly into culture, right? And advertising and medicine and
and now there's comedy and all these other kind of like niches.
Exactly. So, I think the key thing here is we're building all of this technology ourselves on top of open source.
Okay, so talk a little bit about, because I think this is an interesting thread to pull. Like, how did you build software back before things like cloud hosting were around, or before you could get all these kind of finished projects off of the shelf, like as SaaS, like really before the era of software as a service?
Happy to talk about that. So basically, it started with bare metal and Linux, right? Linux was, I don't know, just revolutionary development in my opinion. And because we could get that for free, and we could rack a server, right? Or just a tower, we could run that there. And then we could run the Apache web server. And because we could run the Apache web server, we had like the ability to do that. We could run IMAP, and we could run SMTP. And, suddenly we had the ability to give everybody email address. I think what really was key for me is bringing a really smart person in the organization who was running an ISP. So it was already providing services like email for everybody, right? I'm like, hey, we want an email address for everybody in the company. Right now we have this CompuServe account. There's one, right? Okay. We want an email address. And so it was like, okay, how do we take advantage of this open source and this do-it-yourself mentality? Because it's not like there was a manual written on how to build South by Southwest. It was very much a pioneering attitude, right?
I mean, so even email servers, right? Like, it's not like you could create a Google Workspace account and then just everybody gets an email.
I'm back to the day that it was called Google Apps for Your Domain. The day that Google Workspace came out was like one of the happiest days of my life, because we were like tired of running our own email server and having to deal with like all the spam and the inbound and like all the management. It like left to this thing. But we had this idea, so we'd rack a server. Like when we were taking in MP3s as submissions, it was so early that I had to do a deal with an ISP to get a fiber node in our building, right? So we'd rack the metal, we'd put it on this early fiber ring, and now we could suddenly have
per second or
10,000 band supply or 9,000, I can't, how many? It was like, thousands of band supply, and that became the default way, right? And then eventually like other services came up and popped up, and we could just listen to their music elsewhere. They could just send us links, great. But it was this sort of key enablement and this idea that we can rack the metal, we can run the software. And so from there, we went to like virtualization and early virtualization stuff. We got...
What is virtualization for...
Well,
simplified.
So basically, so you've got this bare metal, right? And you're running all your software, all your servers on there, and you're running it on that. But what if you want to have like multiple operating system images on one machine? So you've got this really powerful machine. It seems like sometimes you want to break it up and you want to have effectively an isolated kind of operating system. But, many of those in that same bare metal that's racked and co-load, right? So for us, it was like rack and co-load. It was like pre-cloud, right? So we would do a deal and like leverage South by Southwest to the degree to, the goodwill we could from the data centers and stuff. And we would do a deal and we'd have technology partners. So we'd have CoreNap as a technology partner early on, and we had Grande for many years as a technology partner for early on. And, we were like, hey, and we had the Convention Center actually as a technology partner due to their sort of, once they installed their wireless system. But it was like, we don't have a wireless system in the Convention Center. So we were like, well, how do we bring in wireless? right? Because we need wireless, because without wireless, like nobody's going to stay at the event. None of the media people are going to file their stories, are all going to leave because the connectivity is so terrible. So that just became like, okay, what do we need to enable this really highly productive, highly creative, very pro sort of like pioneering kind of spirit? And then I just translated that to technology. What can we do with RFID? And what can we do with this? And what can we do with that? And well, let's make another app for this, right? And so we built all these custom apps because I could not, like, we need something, or we thought we need something, and it wasn't commercially available.
Yeah.
SaaS wasn't a thing.
One thread I want to double click on a little bit is you mentioned you were so excited when like Google Apps and Google Workspace came out. But prior to that, you had been hosting your own SMTP servers, like creating your own IMAP. Yeah, you're creating your own email service, essentially. Like, I'm curious to just think about from an engineering leader's perspective, like open source gives you the capabilities you need, but you're still very excited to then eventually pay for a solution and kind of abstract away some of the complexity. Can you talk about, from an engineering leader perspective, kind of the value of open source early on, but also what eventually leads to kind of a let's buy something to do this instead of hosting it ourselves?
Yeah, definitely. I think, every technology leader winds up with this constant build or buy decision-making process. So it was pretty early on easy for us to say, there is no system that currently exists to manage all the volunteers that want to volunteer across all these different shifts and do this. So what do? We either don't have that, we try to do it all on pen and paper, and we try to like share it with people like physically, or we build a system. So we're like, PHP's out, cool. Let's build a system to like manage all these schedules at scale. So it's easy. So I couldn't buy it, right?
It's build or do nothing.
The amazing thing about open source is it's just like, you can instantly gain access, and if you're willing to put in the time and the energy and you can contribute to the community, there are lots of smart people who are willing to help you. You can do it yourself. But that doesn't mean for something like as routine, or as routine as it became by, say, the mid-2000s of having email everywhere, it doesn't mean like you want your engineering team and your infrastructure guy worrying about like the incredible uptick in spam that the CEO is getting. That's not a good value there. And so like if you could buy that for $8 a user, or $6, I can't remember what it was at first. It was probably like $5 a user per person in the organization. And you do the math and you look at like, okay, now this engineer can spend their time on something much higher value, right?
So is it kind of like an opportunity cost calculation?
Opportunity cost, yeah, exactly. Because now this person who is working on this, who doesn't have time for the more sophisticated engineering, like for things that we can't buy, or that wholly custom, or like wind up
we're making
driving.
quite a bit more than $8 an hour or a month, or however long it took.
Yeah, right. Yeah. And so you think to yourself, okay, that's a pretty good trade-off, right? And then the other thing that's really great, I think, about ultimately going to hosted solutions for people is just that feeling of like relief. It's just taken care of. Nobody ever said, wow, open source is easy.
Yeah.
That's not the way it is, right? Like, I mean, certain projects have made it like so easy, but like, let's just say traditionally it can be daunting, right? But it's free, right? It's not.
So trade-offs.
Right, exactly. Exactly. So I think what's really important about open source, cost does not become a barrier for an organization to achieve their engineering goals.
Got it. And then just at a certain point, it might make sense to use that engineering time on other things, like building new features or
higher value for the organization, higher ROI. Like everyone's like, okay, so do you want to have your senior engineer constantly babysitting an IMAP server that's like, even though we put in the newest like filtering, and even though we do this, like you're essentially addressing like how readable is the email, important things are not getting through, non-important things, like that's like, I don't know, maybe like it's kind of, I think of Dante when I think of that, and I think of circles of hell, you know, that's pretty, you don't want him doing that, and he doesn't want to be doing that, right? So if you can use dollars to purchase ease and to ease the mind, and to lower the cognitive load tends to be, like, if you can afford it, pretty good idea.
Okay. So coming back to South by a little bit, you basically kind of grew into this role as CTO, right?
Yeah.
And so you were in charge of all the technology across
Exactly.
the organization.
Including the social media, including the digital marketing and all the video, all the audio programs, but also ticketing, RFID, NFC, Wi-Fi, the mobile app, any chatbots that we did, and any partner technology programs that we did.
Yeah.
So a fairly large purview at one point.
Yeah. I mean, people think of South by today as a digital media festival. And I mean, the work you were doing was all focused on digital media.
It was very much so.
What were some of the, I guess, crazy, like, oh shit moments early on where you're building a lot of your technology in-house? Things are never quite as smooth as they might seem from the outside. Do you have any, like, cool stories or tidbits of when shit hit the fan?
Yeah, I mean, the first thing that pops to mind is, like, we, early on, I was in charge of, like, making the registration badges too, right? And South by, like, prior to my arrival, has started using FileMaker Pro, and then FileMaker Pro, like, became, like, relational, and it just, like, it's really easy to spin up GUI on that, and it became, like, the default sort of internal working thing. So we were making these badges off of these layouts in FileMaker Pro, like, printing them out, like, right? And we were printing them all out, like, in advance before for a while. And
was this before RFID?
Yeah. And we were printing them all out in advance, and then, like, things would go, they couldn't find them, it couldn't get missing. So eventually we're like, you know what, we're gonna do just in time. But that meant that we were building and, like, printing these badges.
Just in time means as people order it,
That's
they
right.
get it.
So we're not gonna print anything in advance. Nothing.
Oh, okay.
We're not gonna print anything in advance. People are gonna come up, talk to us.
Badge pickup.
Then we're going to give them, and we're going to make their badge, and they're going to pick it up, right? But we were doing it all out of, like, this FileMaker Pro database and this FileMaker Pro server, and the server had to be located kind of nearby and on site and stuff. And we were just dumb and, like, had stored it in a secure room, but that secure room turned into, like, somehow magically during the event storage for other people too. Someone kicked the server and knocked it out right at the busiest time where people were picking up their badges.
During badge pickup.
Yeah.
The
busiest time. Like, the busiest time.
For those that don't know, South by badge pickup is, like, kind of a crazy, even still today, like, a bit of a shit show, right? Like, there's long lines everywhere. People are waiting outside. It's hot. You got to go up, and it's gotten a lot smoother over the years.
So this was early on, and we were doing it this way, and the server, like, in the middle of there being, like, a large line, the server got kicked. Like, the power abruptly got cut off.
Yeah.
Right?
Not
so what does that?
shut
So
down.
what does that software want to do? It wants to rebuild, and it wants to, like, reboot, and so just getting it turned back on. And I was, like, really, I had been working a lot and stuff. I was like, I got to go eat lunch. And I tell sort of someone I left behind, I was like, hey, if anything happens, just call me and let me know, right? So go eat lunch, have a nice lunch. And I come back, and first person I ran into is a CEO. And he's like, what is happening? When is this going to get started again? And I'm like, nobody called me. Nothing. And I go into the tech area, and, like, everybody's frantically, like, losing their mind trying to figure out how to restore this thing so people get their badges. Needless to say, it was not good. It was like 2 hours or something before we got it up and running. People were not happy. And so that was really dumb of us to store that server there, but we also didn't have, like, data closets they'd offered us or anything, and it wasn't. So anyways, you asked about shit show moments. That was one, definitely.
Yeah, I mean, the infrastructure for having server racks, convention centers, probably, like, what do you mean?
This was pretty early on.
Yeah.
This was, like, we were still, like, making these badges out of this FileMaker database in real time for when people showed up. And it was also before the event got so big.
Yeah.
Right. And so eventually we're like, okay, we got to get smarter about this. And South by does it a totally different way now. Right. And like RFID came about also just because we felt there was a year where some wristbands had gotten counterfeited.
Yeah. Oh, for sure.
Right.
Every year, Scott.
Yeah. But, you know, and so like that was the kind of drive behind that. So like early on in that. But what we discovered was there's really no vendors to like help us have a mobile fleet of RFID readers that all worked over LTE. So we built it.
What was that like? You had to.
It was awesome because
now
we were like
integrating software and hardware and buying these systems.
Well, once we realized that we could add like a dongle that did RFID 13.68, I think, and we could add that to an Android device. It was on. It was like suddenly we were like, okay, great. So
yeah, because you can buy these things off the shelf,
right? And so then eventually we were able to like get rid of the dongle and like have it integrated, right? But you just buy it off the shelf, and we just wrote the software to run on this thing and to leverage that, and so it could check that was a valid tag. 2, check that person has that credential kind of thing, right? And eventually we were able to do some pretty sophisticated things, which they still use today. But also you get real-time data from across the event.
Yeah.
So we built like this like large telemetry stuff that we kind of figure out. And you know, the idea is just really to like, okay, where are things jammed? Where are they not jammed? Like South by Southwest, like managing the event successfully is about a game of reducing friction. So when I talk to people and I think about, okay, what is the problem I've been working on? I was working on the problem of reducing friction in a large scale dynamic ecosystem with tons of people going dispersed across hundreds of venues and load balancing the event. Right, that's how I thought about the systems problem. So you think about, okay, reducing friction. How do we reduce the friction of that? How do we reduce the friction of that? And sort of real-time data and telemetry from, you know, we don't care who is going where. We just want to know like that badge went in, that ticket went in, and like being able to have that operationalized and be able to make decisions based on that was like, I was a very proud moment.
Yeah. So I've told you before, but I was an intern at South by my senior year at college, and I was on the government affairs event logistics team.
Yeah.
Which is like basically a very fancy way of saying that I would like go around and give people parking permits, but also we would make sure that we collaborated with the government on things like
super important
capacity,
super important
fire,
partnership
security.
with the city, and like really being able to this super important.
Yeah, and there's this I think they called it like Mission Control Center, but it's this like big room with this giant TV, and you could see all of the different venues that had active events going at the time, and then how they were tracking towards capacity. And all of that was based on this RFID scanning system.
Yeah.
And you have like green, yellow, red because the fire marshal's really strict about making sure there's not too many people. There's now like all this crazy infrastructure with cameras set up literally throughout the city to watch for threats, and a lot of like counterterrorism groups come in. And
I think that the main takeaway is if you want to do something big and complex, technology can really help you.
Yeah, well,
and it can help you keep people safe and also sort of make things run better. And in general, like good tech reduces friction, right? That's the way I think of it. It's like, how do you make something as easy as possible? Like good technology should just sort of disappear.
Yeah, it kind of touches on that thread with open source as well. Like the best technology is where you take that friction of managing your open source infrastructure and just take it away from you, make it seamless. We talked about it a little bit, but South by is obviously one of now the biggest festivals in the world. It's grown quite a bit since you first began there. I think that it drives the economic equivalent of a Super Bowl to the Austin area every year, which is pretty exciting. Every year,
special.
Exactly. Talk a little bit about what it was like kind of scaling the organization from a leadership perspective, right? What is it like kind of managing everything that flows under technology as technology is becoming more and more important to the organization, and the company itself is just growing quite a bit? Like, tell me some of the things that you experienced and learned through that process.
Yeah, I think I learned a lot about sort of managing people and building teams. And I think that it's like the number one thing I would learn is like essentially like not everybody's built equally, right? We all have like things that we're particularly good at and things maybe we're not as good at, and we have sort of like things that we're more excited about and things that we're kind of not excited about, right? And so like the idea is if you can find that magic sweet spot where somebody's really excited about something and they're good at it, even if they don't have the skills today, but they believe in what they're doing, that's just magic, because then they can grow into the role and you can shape that and you can give them feedback and the learnings come together. And the only way you go from like a person having to do the Perl scripting and the database design and everything else to what it became was to find those real people who are really just as excited. And so I think that's really key. I think enthusiasm over experience is one thing that I learned. Mm-hmm. Also, South by Southwest, I think attracts just generally like a young brand of like a young group of people. It's got really like great energy on that thing, and so there were a lot of young people that were always interested, right? And so then the question becomes is like, okay, how do you harness this, and how do you create accountability and responsibility, and what does that look like, right? And so the lessons that I learned more than anything was like, I don't have all the answers. Not in a long shot do I have all the answers. Mm-hmm. But when the team is like working well as a team and people are sharing their opinions and being honest about what they think, you work it out, right? Mm-hmm. And then ultimately, when you build towards a decision, whether it's a consensus-based decision or more of a top-down decision, like kind of having that trust that teams will just then execute on that vision, that's really great, right? So it's the best of both worlds. But if you believe that the best idea can come from anywhere in the organization, from the person who started 2 days ago at the reception desk, they could have the next great idea for the business, then you basically want to create a sort of space for those to evolve, right? And so the person that wound up running content for me early on was the receptionist. Wanted to move out of that, wanted to do more, was able to write, was able to put together some things, like knew how to build stories, who thought about media and thought about stories. So when the opportunity was presented itself, it became that kind of flow, right? And so it's kind of like you control your destiny. And I think that's easy to do inside an organization that was not ever, traditionally hierarchically managed, mm-hmm. right? And so that's the other big lesson: flat. Keep it flat. Like, if you can function well in a flatter organization, there are a lot of benefits. The problem with real hierarchical organizations is people get convinced of their own importance in their various positions. Yeah. And then it's like, I'm too busy doing the business of work to actually do the thing that would make a difference to the business. I think that's a real pitfall, yeah. Right? And big credit to the South by Southwest co-founders and to the leadership there of sort of being able to enable that flatter organization and to be able to sort of create this sort of kind of unity as a result. Mm-hmm. Now, there was plenty of disagreements, right? This department's not working with this department. We still had areas and stuff, but it would be a mistake to have a lot of hierarchy in an organization of that size. So when I started there was about 12 people full time when I started full time, and then that grew, I think, as large as something like 175 people at one point.
And how big was the technology organization?
It's pretty large at one point, and it's maybe 35. Yeah, pretty good size. Yeah. Right. I think, as SaaS continued to develop and as event tech developed and stuff, we were, able to deprecate things, right? Mm-hmm. And so and also we eventually moved things around in the organization, maybe we should consolidate the marketing, right? Yeah. And does the social media marketing really belong in the tech group? Probably not. Yeah. You know what I mean? And so we did a lot of that stuff and kind of offboarded. And that's when a lot of that is when I became Chief Innovation Officer and kind of really, focused on sort of pure innovation, yeah. And driving things like personalization and beacons and being able to do sort of like, and then using sort of AI. That's where I first started, using AI in terms of convolutional neural network to help do sort of grading across submissions. And I think,
interesting.
yeah.
So South by has this thing called panel picker, right?
Right.
Where anyone can submit a panel and then the public basically votes on topics that they would want to hear.
Right.
And so you guys were using convolutional neural networks to kind of score and rank those?
Yeah.
Or like sift through it a little bit?
Yeah, I would call
That's
it
cool.
experimental.
Yeah.
Okay. But it was there, and then all the real scoring, ultimately, you could say, that responsibility remained with staff.
Yeah.
Right. But we were able to take, 5 years of data, and what it was really good at doing is kind of quickly giving an indication on the really low quality proposals. So I'd say the C's and the D's, if you go A, B, C, D.
Yeah.
And it did a pretty good job on the A's. And then the B to C is like really where it got fuzzy.
Yeah.
Okay. And so, ultimately though, it wound up meaning, okay, so you could take probably that bottom quartile that scored really low because it was incomplete, really off base, doesn't have a lot of the same features, doesn't have a lot of the same features for the things we've scored well in the past. And that allowed at least the staff to really increase the amount of time they were spending with the A's and the B's.
Yeah.
To really make sure we get the best, right?
Yeah.
And to have more time for deliberation and more time for thoughtfulness and more time for curation, right? So that was the first taste, I think, of being able to use AI, and I loved it. It was great.
How did you structure things like panel ideas or topics? It's a very subjective thing, right?
Right.
How did you structure historical data so that you could feed it into a model and then take new submissions and kind of run it against that to see how they might score? How did you think about doing stuff like that?
Yeah, that's a good question. Because this is sort of pre-LLM and stuff, we also work with a partner. We're one of the early clients of Kung Fu AI.
Yeah.
So we work with the
Shout out
partner
Kung
on
Fu.
that. As far as sort of how we were doing the embeddings, that was very much in their team. And it's been some years now. I can't exactly recall with the state of the tech at that time, but we were doing embeddings. Yeah.
Okay. Share for part of the goal of this podcast is to explain technical concepts in a way that's easily accessible. What are embeddings and what is their importance in this world of AI, especially with LLMs?
Yeah, so so embeddings this is a good question. So embeddings wind up sort of being able to take advantage of vector space, right? And so you've got
What is vector space?
Oh, what is vector space?
Yeah.
Oh,
I'm just going to keep asking why.
Okay,
until
all
we
right.
drill down. Yeah.
Right. So I think, vector space is a way of basically having a multi-dimensional sort of space. And then ultimately, when you're dealing with embeddings, you're trying to get to the root of I guess an ontology, right, of that. And so if you're able to apply an embeddings algorithm towards sort of a data set, and you project that into vector space, which is a multi-dimensional space, larger than 3 dimensions, right? You might have 128 dimensions or something. What you find out is that king and queen are kind of not that far away from each other.
Yeah.
Because there's sort of a concept there.
So
right?
I love this example of king and queen, but just to take a step back. So an embedding is a bunch of numbers, right? A list of numbers. And those numbers represent coordinates in this theoretical higher dimensional space.
Yes.
Yeah. And if you place those coordinates together, the coordinates for the word king are very close to the coordinates to the word queen.
Yeah.
Right?
That's right.
And actually, if you take the word king and you add the word woman, if you add those two sets of numbers from king and woman together, that is even closer to the word queen.
Yeah. It's
right?
a way of doing math with language.
Okay. Math with language. That's a really great way to describe it.
Yeah. And so
why is that so important in how AI functions?
Well, I think that ultimately, why is it so important? With generative AI, for instance,
Yes.
you're predicting the next token, right? And that token winds up being related to that vector space, right? Like, and so you've got sort of all of these active sort of dimensions in the context window. And all we're trying to do is predict, given all of the tokens that have come before that in the context window, what the next one is, right? And this gives us a way to do that. Like, how would you do that otherwise with language?
Yeah. So it's a way to like calculate.
It's a way to calculate language, right? And what you find is, and there's a lot of studies and a lot of people who are way smarter on the like this topic than I am, but what you find is that when you encode these language structures in this higher dimensional space, you're able to compute on it, right? And you're able to compute that next token. We're able to predict that in a way, and because that next token is related to the structure of language, like there's a deep structure to human language, because it's related to that, it feels like it's the truth, or it feels like it's a version of the truth. And it's kind of a magical. It's like, how can you get this semblance of sentience from just predicting the next token? But yet, there's lots of studies in terms of the emergent properties of these once you sort of take this approach.
Yeah. So when you have 100+ dimensions, right, the computers are finding correlations that we as humans don't really understand,
right,
but at least appear to be relevant.
Appear to be relevant and understandable by us.
Yeah, and computable. So I think this is a good transition into like AI in general. So you're in this chief innovation role. You start experimenting with AI. Tell me a little bit about kind of your journey of building with AI and learning about AI.
Yeah, I think, so my personal journey of building with AI, I got into it, I'd say probably pretty deeply in 2023.
Okay.
And, you know, with LLMs, and like I followed sort of ChatGPT when it came out and stuff, but I didn't really start building with it until a little bit later. And
what kind of spurred that interest? You were just seeing the capabilities and you were like, this would be cool to build.
Yeah, so the main thing that spurred my interest is like there's whole new structures that need to be built around this. It's not like the same kind of programmatic kind of, we were doing a lot of web apps, right? You know, so we were doing a lot of Ruby and a lot of PHP and a lot of like all these web apps, and it's like pretty standard, right? And you've got the GUI and all this stuff. But the idea that like the non-deterministic nature of the technology really throws like a huge curveball into engineering design. So what really kind of got me going on that was like the ability to like kind of how do you get consistent, reliable outcomes out of a non-deterministic system?
Because it's not really like exciting. With traditional software, you press this button and this thing happens.
Yeah.
It doesn't quite work that way with language model systems.
Right. And also it's just, you know, I think that there's like just the generative nature of it. Suddenly what really clicked with me was like my interest in like literature and language and linguistics. I did like a decent amount of like work in that area as well in my academics. And I've always thought like language is really special. And suddenly English language is the programming language.
Yeah.
That's pretty cool.
Yeah.
Right? It's pretty cool. And then, so I think like, that got me into it. And, early sort of like, how do you make an agent, right? What is the early multi-agent systems and all of that, like with every advancement. And then the thing that happened as well is like AI code generation has been amazing because, for the last year plus, I've been connected every day, heavily using Cursor or sometimes Klein or sometimes Goose or, Claude Code. And I think the idea that like suddenly all these systems that you can dream about and you think about and all these systems and how do they work together, you can execute them very quickly. And the ability to kind of reconnect with those roots, I hadn't been like in the code for 20 years. Right, really, like day to day, I was like managing people and like managing initiatives and problems and like doing some R&D and like, need be and like having deep discussions on technical architecture and security and all these other topics. but I wasn't writing code.
Yeah.
Right.
You're a layer 2 removed from that.
Yeah, I was a couple of layers moved like for a long time too. And then now suddenly it's like, okay, how do you take, what's really exciting is if you have a lot of knowledge and you have some things you want to do and you're able to like create direction and you're able to sort of, and you're a creative person, just generally, you're a creative person. Now suddenly you can write code in any language. You can, and then it becomes like, okay, how do you harness that? And how do you build really great engineering based on that and not just vibe code something that's going to fall over?
Yeah.
Right? But for everybody who's gotten away from coding, who like wound up in a little more senior role or in a managerial role, I think I'm very common in the fact that like suddenly it's just like you're a kid in a candy store again. You remember what's great about programming. Mm-hmm. You remember this idea that I have this idea and now there's this thing that exists because I had this idea. And that is an electric feeling, right? And I think very connected to that first experience I had when I wrote my first program, like on an Apple II.
Yeah.
Right?
It's like this magical kind of experience.
It's magical experience. Yeah, exactly. The ability to do that. And now I'd argue that like the more engineers than ever, can sort of tap into that, and more non-engineers than ever, right? I think it's a pretty interesting period where you've got product managers who are, posting PRs based on working with Cursor Agent and Slack channel. Pretty wild, right? And then it becomes like, what are you building? Like, why are you building that? What's important about the way you're doing that? And also, you still have all the fundamental engineering things like, okay, how do you avoid tech debt? And how do you not over-engineer a system early on when you don't, that's like a real common thing. Like, like I build engines, so I'm going to build the biggest engine I can. Well, do you need the biggest engine? And how long does the biggest engine take to build? Only 6 months. You don't even know if it works, right? Yeah. And so like you've got all those common things which would never go away. But what's really exciting is you can just throw away a design that's not working and be back to where you were in 2 days.
Yeah.
That is empowering, right? Like how terrifying would that be? If you built this large system and you'd spent all these months on this system and you're like, we'll just delete it. Like, we don't like the way this designed. We're just going to delete it and we're going to rebuild it. Like, that would be, anxiety producing. But what's amazing now is you can do that. So like sunk cost fallacy when it comes to code, I don't know.
It's not.
It doesn't hold up.
Pervasive, yeah.
Yeah, I don't think it does. And like, so the ability to just be like, okay, I went down the wrong path and I have these learnings that I went down this wrong path and I don't have to figure out how to save this badly damaged thing. I'm going to start from the beginning and take all of that knowledge and the way I've packaged that and the way I've written for LLMs to consume my designs and regen. So like that's very exciting for an engineer. And I've done that multiple times in the last months, right? I've been like, okay, this design is not really gonna solve in this way, right? But then because you spend like 2 days or 3 days getting to that design, or I have a design I worked on for weeks and weeks and weeks, I decided to throw it away because I knew that I could generate it again in a better way.
Yeah.
Because I have all the scaffolding, so to speak, right? And I've gotten smarter about how I'm like avoiding pitfalls.
Yeah. Let's talk a little more about generative code because, I think the reason we're sitting here today is like I discovered generative code and all of a sudden I can build full stack applications. But I also lack a lot of that actual formal engineering training. And that holds me back, right? There's certain things that are just take me too much time to do fast. And so I'm curious, like, I guess one thing it makes me think about is, are engineering degrees still valid? I think there's a lot of hot takes that are like, oh, don't go to school for engineering. But I kind of think about it as, math in high school. You always ask your parents, like, well, I'm never going to use this in life. Like, why am I learning this? You're learning it because you're learning how to problem solve, right? In a specific format or way. And I feel like engineering training, like getting an engineering degree or having a formal engineering role with mentorship or leadership is kind of that same skill set of understanding common pitfalls, navigating them, et cetera. And for that reason, it'll always be valuable and important, even when we have this era of generative code where you can tear things down and rebuild them from scratch. I'm curious for you, as someone who has that kind of formal background and is also doing tons of generative coding, like what are some of the limitations that exist, right? What is it good at? What is it bad at? Do you think eventually it'll overcome these limitations? Like, let's just dive into this topic a little bit.
Yeah, so that's a good question. I mean, I think that so it's really not that good right now to things you would call tech debt.
Okay.
Right. And say that would be the number one thing as an engineer. You'd love to wave a magic wand and like erase your tech debt efficiently. But like any system that you've built over a long period of time, or even a shorter period of time, sometimes, especially if you wind up pivot, there are things that you wind up doing and you're like, why did we do it that way? New technology comes out, new things get patched, like people get smarter. And so you have these parts of these working systems, but when you're like, particularly in production, operating a production environment in some way, like, or like iterating between, like for clients very quickly, it's difficult to address that tech debt without just sinking lots of time in. And so, I think that, that becomes really complex if you're working on like large coder bases, like, over 1 million lines of code with a lot of tech debt. You're probably going to waste a lot of engineering time if you take a code gen based approach to that.
Why is that?
And it's because ultimately it all comes down to context.
Okay.
Right? But the thing is usually when there's like systems with technical debt, there's like weird reasons why, or business rules. There's like unspoken, undocumented context.
Can you, I love that kind of like analogy or description. Can you give a specific example of kind of the background business logic or context that might be lost in the actual code and create tech debt?
Yeah, I mean, I guess it would be like, it's hard to give an example in the sense that I haven't encountered this specific problem really directly, like recently. But I would say like a good example is there's some other system that your code base doesn't know about. Right. And there's a reason why you've got the IDs, or you're doing a handshake a particular way, or like there's a way that you're handling like the token refreshes or whatever it is. Right. Or there's sort of like why is it that we have like, we built this thing and we didn't build a multi-tenant system. We just built single tenants, and we like, now we got like, then we got too busy with customers, and now we're like have to recreate the entire environment every time. Right. Well, like, it's hard once you sort of have contingencies based on code bases from other systems that are not directly referenceable by the LLM. Forget it. It doesn't have the context. So it does come down to like whether you've got context. And typically when you've got really large code bases too, you've got limitations of context window, but even in larger context windows, there's various sort of like studies done related to like whether an LLM is going to do well with a piece of data based on where in the context window it's located. You start to really get into some, like, you just get lower performance out of generative systems. So I think that's an area that's like, you're better off having an engineer who knows the system. Well, and then also like you would have a similar problem if you had a new engineer and you put them into a code base like that, right? They would probably do okay with like that, like querying the LLM to say, here's the context basically, but it still wouldn't know about anything outside of that system or some business process that's the way it comes in on accounting, and we can't change it because we've got this long-term relationship with this particular vendor, and that's why we're doing it that way, because they don't have this other API service that we need.
It's like tribal
knowledge.
Know
that.
Yeah.
Right? Yeah, it's tribal knowledge. Yeah. And so either you have to build the context of that tribal knowledge and you have to document it within your organization, which obviously is a good idea because you want to have, like, forget LLMs, you want to have continuity, when you've got senior people leaving,
Yeah.
and you want to be able to get younger people involved in that quickly. But I don't think it's very good with that. It's extremely good going from 0 to 1, right? Because it basically doesn't have to learn a legacy context.
Yeah, it can just start from scratch based on what it knows.
That's right.
Create
Exactly.
this outcome.
So like fast prototyping, it's exceptional, right? You know, like, and I think a lot of people have experienced that. And I think, you know, right now this road is being paved right now. People are cutting their teeth on how do you build reliable, predictable, well-engineered systems while taking advantage of the speed that is offered by AI code gen. You know, verdict's still out. Like, how serious can you do on the engineering side? My approach is, and I think it's pretty great for being able to like quickly build a full system, but then you can also leverage it to build all your testing apparatus. And you can basically, the way you get to hardened systems is through that kind of testing and discipline and load balancing and security scanning and so you might mix in some open source thing. Let's run these open source or like security libraries against this or whatever to kind of gather your information. And then you're building your context. You're building like that context for hardened production apps that it needs, right? Because mostly the things I've talked about where it hasn't worked well has been a function of a poorly managed context. Because the models are that good right now. I mean, they're really impressive, right? But will it still get things wrong? Yes. Does it get things wrong as much as humans? I don't know. It depends on the skill,
on the human.
right? Yeah, exactly. But what you can't deny is it's going to give you something you can make better, particularly if you're engaged, and particularly if if you've never coded before and you've never looked at this code, you're going to have a hard time. Right. You know, but if you are willing to learn like sound engineering and you like read about engineering and you think about like what makes a good system design and you read about those things, when you come across them, you don't even have to remember all of it yourself. You're building your context.
Yeah.
Right. And so as you continue to have those like grab bag of docs, like I call them my LLM docs. Right. These are my docs related to the system that I'm building that have all kinds of elements to them, and you kind of build that sort of like structure for yourself, and you can dramatically improve. The other thing I think LLMs are really terrible about doing is like, and one of the big tendencies of I'd say agentic coding is that if the agent gets turned around, starts modifying a lot of stuff, it can get kind of in a labyrinth. Like I think of it getting lost in a maze. It will never get out of that maze. Yeah. Okay? But that's why Git is your friend, right? Because if you're committing and pushing, and you're using Git, you can hard reset, you can just declare bankruptcy. And I promise you're better off declaring bankruptcy on something that's like a fast project if you go down that road because the LLM will never get out. It'll like, you'll say, hey, this is how you need to change it, or here's an old version of this, or like, hey, let's like make these adjustments or whatever. Don't have it move files around your file system. It's a little bit better at that now than it used to be, but you're just asking for trouble. If you start using the coding agent to like rearrange your directory, don't do it, probably. You're a lot better off just like doing it yourself. And those are the things that I've encountered.
Yeah, I've definitely gotten lost in the maze a couple of times, and you kind of just got to completely exit out and start fresh.
That's right.
Actually delete all the context from the existing conversation. Because like what I've noticed is there will be a bug or an error and it thinks it's this thing, and then it's just convinced it's that thing, even when it's not.
Right.
So it'll keep trying to fix an error that is not there.
Right.
And just keep getting more and more twisted around and messing with more
the pitfall
files.
here is like, it's possible on really complex tasks, particularly if you're getting turned around inside a code base with the agent, to spend a lot more time trying to solve it.
Yeah.
Or you just like wipe it out. You're almost always better off.
Yeah.
I mean, You know, if it's like, that's where it gets scary with legacy code bases. You don't really like, okay, if you've got over 1 million lines, you've got 4 million lines of code that the primary architect is an aging engineer. You better start building that context.
Yeah.
Do you know what I mean? Like, you've got to have that like really deep context to be able to do that, to have confidence in it. But you need that also for continuity with younger engineers.
Yeah.
Right?
There's some interesting companies too tackling that problem and creating synthetic context or layers of context. I think that that's a problem that will continue to improve and get solved better.
Yeah.
So you are now building a company around AI. Let's talk a little bit about that. You started kind of really actively building stuff with AI around 2023. What was kind of the journey to starting your company, Janix? And like, walk us through those early days and kind of what led you to be so excited that you're like, you know, I really want to go start another company.
Yeah, I think the thing that, well, one, it was a great area to work in consulting. There was always new problems. There's always new things to build.
So yeah, I guess taking a step back, you leave South by after 20 years?
26.
26 years.
Yeah.
Pretty incredible. Seeing tons of growth there. And then you start
consulting. Yeah. I've always really had an entrepreneurial spirit about me. And it was a really good way to kind of like have a nice, easy transition. You know, I did some traveling, take some clients. Sometimes I'm busier than other times. It's actually, you know, a really nice way to kind of like, but the downside is you never go very deep. You never go very deep in any particular problem, and you're constantly like changing projects from one thing to the next. And it's hard to feel like in a world with like one, if you're exploring, it's great because you get all these at-bats in all these different situations. But I really like to build. I like to build durable, impactful, long-term systems. And so I always knew it was kind of a transition for me, right? And it got me super hands-on again, right? From executive, where I'm managing managers who are managing individual contributors, to I'm doing all the individual contributions and working with people that I bring in to kind of like augment, right? So that was awesome. And I just sort of like fell back in love with building systems. And then when Model Context Protocol came out, I was always constantly like looking at the latest evolution. Okay, here's this model, here's these agentic structures, here's multi-agent systems. It's like really kind of, but as you know well, the development of AI is like blazing fast. It's super vast. You can spend all day, every day, just keeping up with what's happening and never build anything, right? And so when Model Context Protocol came out, it was like the first open standard for AI, interconnectivity. And the connectivity between LLMs and data sources and APIs, I'm like, I'm in.
So let's take a step back. Explain in simple language, what is Model Context Protocol?
Sure.
Yeah.
So Model Context Protocol is, when you say protocol is a set of rules for how two systems might talk to each other. Okay. So protocol, that word. So the TCP/IP protocol, which people have maybe heard of, right? Underpin the internet, right? You know, the HTTP protocol is the set of rules for web servers and web clients, which are browsers, to be able to work consistently together. And that means that I hit the mic. That means that anywhere you go, a web browser should be able to read a web server, right? It's not like everyone's inventing their own language for that. And so like this early like AI, like particularly generative AI, like how are we connecting this in, and how are we going to integrate this in, and how are we going to integrate that in, like everything winds up being really bespoke and really custom and really particular to the use case and the client. And so then that winds up being like it's difficult to not like constantly, like you're not building a foundation to build upon. Right? You're constantly building bespoke, custom roads, right? So with the protocol, where you've got a consistent series of rules for servers and clients to talk together, because Model Context Protocol is a client-server protocol, not unlike HTTP. But in this instance, the MCP client or Model Context Protocol client typically is connected to like the LLM in some way, whether through a chat interface or as an agent. And then the MCP server is serving context. It's serving data from databases or serving data from APIs, or it's interacting with these systems in some way, right? Like if you just think about CRUD, create, update, delete, read operations, you can do that now, like in a consistent standard way, which means that any MCP server that you have, you should be able to talk to it with an MCP client, right? And so that standardization really reminded me of like the early days of the internet and the web and what TCP/IP and HTTP and other sort of protocols unleashed.
So kind of in the same way that HTTP, which is itself a protocol, enables a web server, right, to share data to the web client, which is our browsers.
Right.
Model Context Protocol allows data servers, right, so some store of data, to interact directly with us via these models, which are the clients.
Yeah,
Is
that's correct.
Okay.
And it's really even extends beyond just data, and it's like any system, right? But it's a way to externalize that system. And so MCP servers, like the most popular primitive of servers, are tools. So an MCP tool is kind of extruded by that server, made available, and the LLM can reach out and use it. And that's pretty cool, right?
Okay, so let's dive into a specific example. Let's say I have a company and I've got a bunch of sales data in my CRM, and I want a way for models to interact with that sales data. I could create an MCP server that has a tool like read deals,
Right.
basically. And now the model can plug into that tool and use it to read the deals in my server without me needing to move my server data around or expose the entire database to this system. Is that correct?
That is 100% correct. And so basically, because you have this interface that's designed for LLMs, then it comes down to is like, what does the LLM want? Like, if I say get Jake's profile in our backend systems might kind of be split among a bunch of different systems. Like we might have his like username over here, and then maybe we have some data about his like demographics over here. And maybe we've got some data like his entire history of everything he clicked on our site ever in this whole other system, right? Mm-hmm. But what we want really, what we want when we're chatting with this, or when we have an agent that's asking for it, is like, we want Jake's profile. We want to understand all of Jake's data, whatever that means, and we want to have that payload, and we want to be able to bring it into the context window so we can interact with it, right? So now we've got it in the context window. But that's already 3 different systems. So either you wind up having to create like 3 different roads that are custom roads to each of those systems to integrate directly in whichever way you want to do, like say you do it with an API or something. Now you've got these 3 different calls. If that backend system storing Jake's whole history needs to change and the API needs to change, it would just break everything.
Yeah,
right.
It's very complex.
It's complex and fragile, ultimately, because you've got all these hard-linked contingencies, right? But if you have to build an MCP server, right? But if you had an MCP server, that you could have a tool say get Jake's context, and in that tool, it was doing the connectivity or whatever.
So the tool itself would interface with the databases.
With the databases and all that source. Pull it in and shape it, and then shape that context payload, right? So it's like served up on a platter, right? And so like now we know exactly what's in the payload of that, and it can serve that into there. Now I've got this get Jake's context that I can use in this chat system over here. I can put an LLM that runs every day at 4 o'clock that leverages it over here. I can make an agent doing something else to leveraging Jake's context. And now like all I need to do is maintain that Jake's context tool, right? And if you wind up making, you can also then into those same ecosystems shape that tool and continue to shape that tool to serve the context, or make a new tool for a different use case. But what it allows us to do is those interfaces between the LLMs is there's a description, the LLM can read that description, and so it enables agentic behavior. And by agentic, I mean a decision-making system that's using tools, right? So this LLM is looping on itself. It's got a task. It says, go ahead and create a recipe that Jake would like based on his profile. Right? Mm-hmm. So it goes and it can get that profile, and then it says, oh, I've got this tool I can use. Which of these tools should I use? Get profile data for Jake, or should I use this other tool that's like save recipe, or should I use this other tool that's like, I don't know, read the history, mm-hmm. right? And so it'll make a decision, and it can know enough about that tool that it reaches out and uses that tool. So it's decided which tool to use, right? And so that agentic behavior, because it's going to use that tool in service of a task. And then once we've set some sort of exit condition, you've completed the task when X, it can do that. But now you can just have these tools in this network, and you can provide it to all your agents. And if you want to add another tool, instantly all of your other run flows could access that based on networking permissions, right? And so you've got this less fragile. Yeah. It's more robust and more, it's easier to plug and play. So if you think about this world of like really bespoke AI engineering and bespoke sort of like working with customers and stuff, now if we're into a world of plug and play, interoperable servers and clients, other people can write clients and servers that I can use really easily, that's very exciting, right? And I think that same explosion that enabled for the World Wide Web, this is going to enable for AI workflows and agents. And so you're sort of building, what's exciting about it is it's not like this is how we've always done things. You're never going to hear that, right? It's like we're inventing the future. Right, we're inventing the interoperable AI, like secure, monitorable, observant, auditable, and when it comes to running these sort of new novel decision-making systems based on LLMs, the story is being written right now, right? And so there's a lot to discover. It's very adventurous, and that's what makes me enamored with it.
Cool. So you got really excited about this technology. You then made the decision to build a company around it.
I did.
Right. So what have you learned since starting on that journey, and like what, I guess, problems can MCP solve for customers to turn it into like a really interesting business?
Yeah, that's a good question. So, so I decided to start a company based on this, because I also feel like this is going to be it's going to take a little while, right, to really get suffused, and then also the opportunities of today are probably going to be different tomorrow. But the key thing here is open standards, and through standardization and interoperability, we get something that's greater than the sum of its parts, right? And we get community, and we get open source. And Model Context Protocol is also open source, which is really exciting, right? And so you've got community contributing to how are we going to create the interoperability between these systems going forward. I think like as far as the opportunities, well, number one, I think a lot of people are using chat on a regular basis. But one of the things that's difficult right now is I want to chat with my data, and I want to chat with my systems. And when I say to chat, send a message, I want it to send an email. Mm-hmm. And when I say, remind me of something, I want it to send me a text message, and but to my phone, right? And if I'm a business, right now, I really am trying to have a hard time understanding what the trends are in terms of our sales, but if I have the ability to talk to my sales system through my chat interface and I could just get answers back, that's pretty cool, right? And so I think for every business right now, the question is like, in people when they're using chat right now, I think a lot of people are like, let me copy something over here, and let me paste it in here, and let me take the thing there and paste it back there. to be able to get some of that. How do we bring context into this chat that is deeply personal and specific to my needs? Well, the number one way to do that is through tools. And because we're standardizing on MCP, then the idea is you can have MCP tools, right? And because there's a lot of open source tools that have been written, I can go find some tools that connect to my system and I can use them. And then now instantly I've like built something greater than my chat universe, right? I've built something that goes beyond the walled garden of ChatGPT or Claude AI, or I'm using something like Cursor or VS Code if I'm on the coding side. But I want to be able to quickly pull context from these highly relevant data sources that I need to interoperate with. And so any companies can use that, you know, for a variety of solutions. The other thing is it really enables agents in an easier plug and play way, right? So you can take an MCP agent, whether an open source one like MCP agent or a fast agent, or you can write a custom agent, or you can use one of the agents on somebody's platform somewhere, but you don't have platform lock-in because it's just an MCP agent. So you can take any MCP tools elsewhere, put them in a network with that agent, and you can make some results from that agent using those tools.
You get the same capabilities, but with different systems.
Right.
So this get profile data MCP server, you can have that at South by Southwest. You could theoretically also have that at, you know, Antler where Jake works, right?
Exactly. And so that interoperability, where you've got like interoperability and standardization enables marketplaces.
Okay. Tell me more about that.
Well, it's really hard to sell a bunch of things that don't talk to each other. Like nobody's going to buy a USB plug if it doesn't plug into their Thunderbolt and all they have is Thunderbolt, right? Okay, well, I guess these two things are not going to be able to talk to each other. But that's why USB became so pervasive because of an open standard. Hey, everybody, let's make all the plugs the same. Let's make the data, like, let's have a standard around this so that we can create a marketplace. Now, suddenly, there's a marketplace of USB devices. I can get a USB microphone. I can get a USB camera. I can get a USB thingy for what I need, right? Because there's a standard. Well, with AI, same thing. Now there's a standard for interoperability between LLMs and data sources and APIs. So now I expect over the coming months and years for marketplaces to develop around this, like on the business side and on the personal side, to be able to sort of have that interoperability, right? Or in audio, you've got your DSP plugins, right? And so if you're in the standard of DSP, you can sell your plugin, and people who have Cubase or I don't know, which audio systems, Ableton or whatever, they can just plug it in and it works, right? That ability to just like plug it in from one place and plug it in somewhere else means you don't have to keep recreating the wheel either. Once you've built your MCP server in front of your CRM, you have it for any need you can think of. Whether you want a report on like all the deal flow from today and exactly who bought it and like what else they're like doing and checking in our system so that we can get a pulse on like who's coming in today, to like doing analysis on sort of like the finances for that, or pulling up a data set of people that we want to enrich the data for because we don't know much about them. They're in our CRM, but we want to enrich that data. Now I can go, that same CRM MCP server I can leverage for these other uses, right? Because I think what's really interesting is like the idea of the natural language interface. And so if you think about all of these software and all these systems, like the whole idea of back end, right? Well, MCP is like the back end for our natural language interface, right?
Yeah.
And so we don't need the GUI, right? So now you've got the opportunity to create these systems who the primary user of these systems is an agent. It's not even human.
Yeah.
Right? And so what kind of tools is that agent going to make that agent most effective? That's a really exciting area. And I think the other thing that I just want to connect to the grander story of what makes me particularly excited about this area is tools, right? And if you think about like the history of tools and tooling and what tools enable, they enable creative builders, right? And same thing here, right? And so you've got all these new tools, and the people, like someone's going to come along and plug them in together in a way that is novel or new, or connect to a new system in a way that suddenly opens the capability for many millions of people to take advantage of that. That's exciting.
Because it's standardized and interoperable, and they can just plug that into their system.
That's right.
Yeah.
Instantly. So you're building an ecosystem, right?
Yeah.
And I love ecosystems,
Yeah.
right? That's really exciting. And that's the reason why Janix is really specializing in like building and operating and managing private MCP networks for our clients. It's because of when you get these network behavior and you get like network observability and you get interoperability between these components, you can enable like incredible outcomes.
Yeah. Well, I mean, if you think about without something like this MCP system, if I wanted to perform this analysis of my CRM, I would have to export that data, put it into the context window of an LLM. Hopefully it fits. And then it's operating with so much data that the LLM might not have very good output. But whenever I do get the output, I then kind of copy that back in here. And if you want to move towards more autonomous systems, like the human is too involved there. There needs to be some way for it to go directly to the source of the data and capture that and then take the next step. And MCP is an option that enables that capability.
Yeah. Or if you think about sort of one approach to data science and AI has been like, hey, let's leverage the data across the entire company. Let's create a common ontology. Let's create a consistent data catalog so that we can move all this data around. Which is a lot of data engineering, right? A lot of data engineering, a lot of scripts, time, planning stuff to be able to get this into a trainable kind of data set so we can do some machine learning or we can do some traditional training around that, right?
Yeah, you have to do what's called ETL, right? Extract, transform, load, convert that existing data into something else so that you can use it.
So like MCP tools like provides that automatic ETL, right? Because
it's a cool way to think about it.
You know, if you kind of pull that in, you say, okay, all the ETL is being done in the functions behind these tools, right? And so then if you believe like I do that in 5 years there'll be more AI tool designers than web developers, then the opportunities are sort of like endless there, right? And like, because what you're doing is you're serving context and managing context and context engineering, right? For these agentic systems that are capable of scaling beyond human labor and are capable of sort of like really allowing sort of humans to focus on sort of higher level, less systematic, less, scripted kind of approaches, right? And so it sort of allows us to sort of index our work on the messier kind of frontier of complicated systems that we haven't built any sort of traditional way to approach yet, right? Mm-hmm. But LLMs and sort of generative AI and agentic systems provide us with a ability to have this sort of decision-making system that's based on the engineering behind it and the structures of language itself. That's pretty exciting.
Yeah.
I think from an abstract standpoint, I think it's just a great way to spend my time every day. I enjoy thinking about it.
Awesome. Tying it back a little bit to what we were talking about early on in this conversation with open source, right? You said, I think specifically, like no one said open source is easy, right? So MCP is open source, but that doesn't make it easy. And similar to when you had the opportunity to move from managing your own email server to using a managed email server by Google, you like leapt at that opportunity because it takes these things off your plate. Like how do you, now that you're building a company around this open source project of MCP, like what are some of the capabilities that are still complicated and sticky and create opportunities for you to build a product where a customer would rather have this managed by Janix as opposed to managing all the infrastructure open source themselves?
Yeah, so that's a good question. I think that, ultimately, if the goal is to have these AI tools, so what we want is this tool that we can use in chat and that we can have agents use in our agentic kind of flows, then let's talk about what it takes to get there. So like MCP is a protocol, which means here's the way we're going to send messages. We're going to send messages over JSON RPC2, and here's a standard. But the first time a client has to like connect to a server, it needs to initialize, and then we have to follow this auth 2.1 standard, this is how auth 2.1 is. And every server, needs to be able to do this, must do this, or should do this, right? So it's a set of rules, and there's kind of a lot of them, right? So first of all, it's like, how are you compliant with MCP? Because if you're not compliant with MCP, then other compliant clients and servers won't be able to communicate with you, which basically breaks the promise of interoperability.
Yeah, the whole point is you have to follow the protocol exactly. Otherwise, it's not a protocol.
Exactly. So so on a really simple note, I created MCP Validator, which is open source, which allows anybody for free to quickly validate their servers against the specification, and then on top of that, specification continues to evolve, right?
So make sure it matches the protocol, but the protocol itself is continuing to grow.
Right, exactly. There was a version in November of last year. There was a version in March. There's a new version in June. And in every version, there are some breaking changes and some non-breaking changes. And you're supposed to support the older protocols kind of gracefully. So if you're going to build an AI tool for common consumption, then it needs to be able to work with the broadest set of clients that it can according to the protocol, right? And so the other things you have to, that are not so easy is authentication. So the current spec mentions that, you need to use OAuth authorization server, and that an MCP server is an OAuth resource server, right? And also there are rules like servers need to be able to do dynamic client registration, right? And or sort of OAuth provider needs to do dynamic client registration.
These are all criteria within the protocol.
It's all criteria.
That in order to be compliant, it needs to follow.
Exactly.
Yeah.
And so there's a lot of that. So if you think about, okay, not only do I have to build this thing, now fortunately there's all these great SDKs, right? They kind of get me started. So there's the Python SDK, or the Kotlin SDK, or the C# SDK, or obviously JavaScript SDK, and but that gets you so far, right? And now you're like, okay, now I have this server, but what if I want to have a streamable HTTP hosted server? Now I need to host it somewhere. Where am I hosting it? How do I know that authentication can get to it? And do I have that configured correctly? How am I going to manage a set of users against that? How am I going to give them permission to do that, right? And you also have the fact that it's an imperfect science. So you've got different clients like Claude.ai and Cursor and VS Code, all making their best attempts to be compliant, some more than other. Definitely Claude.ai is not up to the spec at the moment, right? Compared to sort of VS Code and Cursor.
And Claude, what's funny about that, worth highlighting, the company that produces Claude, Anthropic, is the company that created the protocol itself.
They are.
And even their model is not compliant with their own protocol.
It's because it's so fast moving. There's so many moving parts. There's all these things, and everyone's chasing the same interoperability and capabilities, but that makes it really complicated. And so if I literally just want to make an AI tool for my thingy that I just want to have so that I can use it, that's really hard right now. It's really hard, right? You've got to be willing to do programming and sit down and figure out how to build it and then try to use it. And then you've got to deal with all the hosted part of it. How do I get that on AWS or on GCP, or how do I make that available to a broader set of people? And how do I manage the OAuth, right, to it? And how do I make sure it's secure? And how do I make sure it's, all of those things. So that winds up being sort of this broader set of a lot of friction, right?
Yeah.
So back to my earlier analogy, I'm really thinking about how do we reduce friction for people that want AI tools with MCP, and that's kind of the broader thing. So some of the things we're looking at are specifically we're working on making it really easy to go from API to MCP. So APIs, there's millions of them, right? And they underpin all these systems, right? And lots of developers, right? But they're built, the REST API is built for developers to leverage, right? And so you've got this set of APIs, and you might have 60 different sort of like API calls that you might make for a consistent set of APIs. And the way current software is built is these GUIs and these flows on top of that leverage a combination of these API calls in such a way that you're accomplishing a unit of work, whatever that is. And
so
that
you might
is
call
all,
this API for this point of data and then call this other API for this thing. And every time you call the API, you're getting a bunch of different data, but you only need this one piece. And then you're going to combine it with this one piece over here.
Yeah, it's very, very much like combined in the back end, right, between all this stuff. And then there's a GUI on top of it. So I can click here and I can see that and stuff like that, right? So now you've got millions of APIs across the entire internet. They're all built for like more or less developers to integrate with. How do you go from that to well-crafted, well-designed, high-functioning MCP tools that agents and chat can use natively, right? So that's an area that we're focused on.
Yeah, and that unlocks a couple of capabilities that I think are interesting. But one that I want to dive into a little bit is many people think about APIs as like external. Like, oh, I ping this API to get this data point from this service. But there's actually tons of APIs that are used for internal processes and internal work, right?
Right.
And so when you're thinking about deploying AI within an organization, you've got all these capabilities, all these APIs that have been built to find different data and different criteria from within an organization. Like, how can you turn that into something that is an MCP tool? And so now, because most of the people that work at a company, unless it's a software company, are not technical, don't know how to combine these different APIs, calls to get into a unit of work. How could you give them an agent that instead could access a bunch of these different tools to complete units of work?
Yeah, and that's exactly, yes. So that is a huge area, but I think there's also sort of like this whole aspect that this internal API was created under very controlled conditions for a programmer to hit it that was also internal, and we know what calls we're making. So most of those APIs aren't hardened.
They're not secure.
They're not necessarily like, do they have rate limiting on them? Well, we don't need rate limiting on the API because it's just this button and this one piece of this application that calls that API, and people can only click the button so often. But when you have agents and they can recursively continue to call something, and they can work much faster than human beings, like, is that API going to break? Is that going to create a problem in the rest of our system? What if, and so it comes down to like those APIs were created for a very specific use case, a very narrow use case, but now you're trying to make it extensible to a variety of circumstances. Even if you're the only one running the agents against it, how do you do that, right? Like, do you have to rebuild the API? Well, it kind of defeats the work, right? So I think we're working a lot on like, okay, what is the processes? What is the thinking, the philosophy, and like what makes a great tool? And then being able to take advantage of the infrastructure that we built to do that. And then to be able to make people to make that tool usable easily as quickly as possible. So those are some of the things, again, in the sort of let's reduce the friction of the ecosystem, because the general idea is the more people who have tools, the more people can use those tools to be to conduct their business or to be creative or whatever, right? And so, in general, making it easy for people to have tools that are meaningful for them, that's the idea.
Yeah. So you're building this company here in Texas. You've been in Texas for quite a while. Let's talk a little bit about Texas as an ecosystem for building technology companies. Obviously, it's not kind of in this pole position of being San Francisco or New York, but tons of really exciting engineering talent here, tons of really exciting companies like Janix being built here. I guess when you think about building your company here versus in the Bay Area, what were some of the kind of decision-making processes or trade-offs that you had to keep in mind? And like, where is Texas really good and exciting and provides a lot of opportunity for building companies? But then maybe on the other side of the coin, like, what do we need to improve on or get better at? Because obviously it's not perfect, or it can always be improved.
Yeah, that's a big topic. Okay, so tackling it a little bit at a time. I think, like, first and foremost, I think that there's an innate sense of entrepreneurial kind of independent pride that underpins the Texan ethos, right? So that's cool, right? People want to do stuff, and they also like we can do things ourselves, right? We don't need a bunch of people outside to do things, right? So I think, you know, that's inviting instantly. I think that the other thing is that from a technology ecosystem, you've got at least like these deep roots in semiconductor here. And there's been a number of companies that have been able to flourish in this ecosystem. And I think there's some really great resources for early stage entrepreneurs, whether it be Antler, or AITX, or Capital Factory, and some of these, like, we do a pretty good on that front. But, you know, clearly, like, there's a huge capital advantage and talent advantage out in the Bay Area. And so I think the things that I've been thinking about, too, is, like, how to build, like, it was important for me to build this company in Austin. One, I've spent, 30 years here and spent my entire earlier career putting Austin, sort of like shining a light on the creativity and like the coolness that is Austin, Texas, via South by Southwest, right? And so like that idea of like bringing people and like showing people like the spirit of the city, it's always been core to me. So I wouldn't want to build my company anywhere else. And so I knew that, okay, for AI tooling and AI infrastructure and for like enabling sort of like the long tail of AI, like Austin, Texas is like where I want to build that. And, but that comes with some trade-offs too. Like I think definitely funding is a tougher proposition in terms of like just the amount of capital and volume and the amount of firms that are willing to take bets on early ideas. It's just much larger in the Bay Area, right? And so I think it's, you know, it's important in Austin to lean into and like find that community to kind of like bridge those early days, because there's not going to be like a wall of money that someone plops down on you, right? Like, and particularly when you're pre-product market fit, or you're pre-revenue, right? So then it's a matter of like, okay, how scrappy can I be? Can I be competitive? Like, and so those are the things I'm struggling with right now. I think, you know, candidly, it's always like, it feels like it's hard, right? Like, and there's a lot of people who decide, okay, I'm going to go to the Bay Area and build my company, because there's just this constant like open receptivity to that, and also willingness and enough, I think, spoils of the gains of technology to be able to fund sort of adventurous tech.
Yeah, density of capital.
It's harder to do that here.
Yeah, I definitely agree with you. And I think about it not so much as like this zero-sum game, but just the Bay Area has done a really, really great job of investing in technology and creating an ecosystem with plenty of capital for people to go after these crazy ideas and build these cool technologies. And so Texas should take note of that and like figure out ways to incentivize similar types of things here.
I agree with you. I think there could be a lot more done on that. Like, I think there could be a lot more done on sort of like supporting innovation in the ecosystem, because there is just a tremendous amount of technical engineering talent. But it feels like, I think particularly too, like we want to be a tech hub, right? And there's certain people who are just doing incredible work here, but where's the like larger institutional support for like innovation, right? And if you think about like the ability for us to be a leader in energy, the ability for us to be a leader in manufacturing, like we need to be a leader in sort of like core technology. And I want us to be a leader in AI, because I think people have said, oh, you're focused, like I think earlier people said, you're focused on AI. That's interesting. Why'd you pick that? I'm like, why would you do anything else right now? It's the most exciting time when it comes to sort of like innovation and the revolution of ideas, like writ large, in my lifetime, right? And so why would you do anything else? I think it's super important. And I think with our economies of, you know, the semiconductor industry, and for all the different sort of manufacturing and hard tech and hardware, just really like it'd be great for us to just be, like top place in the United States and in the world, and sort of like knowing, oh, that came out of Texas.
Yeah, I mean, aerospace, real estate, oil and gas, healthcare, hugest medical systems in the country. A lot of them are here.
Yeah, I don't know if Texas always does the best job of telling its own story.
Yeah.
Because I think you just named off leaders in aerospace.
Dallas has more Fortune 100. I've said this a couple times on the podcast. I really hope that it's like accurate, but I remember hearing during my time,
somebody told me
allegedly, that it's got some of the most Fortune 100 companies that have kind of executives and headquarters in the country in Dallas, which is a 3-hour drive from Austin. So you can do a day trip or a night trip.
Yeah, it seems so weird that that's like under-publicized.
Yeah. I mean, this idea also, like Houston as well, 2.5, 3 hours away. San Antonio is an hour south. There's been, I think, like discussions of creating like light rail systems, or Elon maybe digging tunnels with the Boring Company and having high-speed rail. Like, that's actually pretty feasible at some point in the next 20 to 30 years. And imagine if you could get on a train and go to Dallas in 45 minutes.
Yeah. I mean, here's yes to all that. But pure and simple, back to AI. If AI winds up being, the limiting factor of AI winds up being energy, why would we not try to become the world's leader in AI?
Yeah.
I feel like there's a symbiosis there that will throw off everything else, but it's just like a huge advantage there. Now the question is like, okay, how do we tap that, and how do we do that in a way that doesn't wreck the ecology and the sustainability for the life forms that also populate this area,
which are also important,
which are really important. But you've got like this incredible amount of technology, and I think if Texas really set its mind to sort of like, how do we create sustainable energy generation powering world's leadership in AI. I mean, if you looked at all the states you could do that in, it seems like, why wouldn't you pick Texas?
Yeah, and I mean, we're already making great strides. I think this morning Sam Altman announced a giant data center project in Abilene, Texas.
Yeah.
It's gonna probably double the population of Abilene just with all of the opportunities that it creates. And a lot of these new data center power build outs, Texas is a natural place to do that. We've got plenty of space, right? Like, you drive 15 minutes out of Austin, you're in the hills, and it's complete openness, right?
Yeah, I think that, I mean, yes, you've got that, but that's a California company, right? So the question is like, what are the opportunities for Texas entrepreneurs, and like, what about Texas helping Texas, right? And like kind of enabling that, or are we just a resource for companies where leadership is in like California or New York?
Well, I think over time you might see some of these companies creating bigger presences in Texas and ultimately like relocating and having the majority of them here. Like Cloudflare is, I think, a big example of that, where they actually have been building out engineering and product teams and kind of focusing the growth of the company here in Austin since 2019.
Right.
And so if we have more of these infrastructure projects, better access to power, better talent that comes with building out those projects, they can then get hired in and recruit in, and it kind of creates this flywheel that makes Texas a better and better place. And eventually, like, why would you not have, if not your formal headquarters, like a home base here in the state of Texas?
Yeah, that makes sense.
Well, awesome. I want to move into some rapid fire questions.
Okay,
I warned you about these at the front.
Yeah,
okay.
let's do it.
First question is, what is like a book, podcast, a piece of content that has influenced your personal framework for how to like lead or just live your life in general? Just something that resonates with you.
Yeah. Okay. So one of my favorite books is Buckminster Fuller's Operating Manual for Spaceship Earth.
Okay.
So Buckminster Fuller, really revolutionary thinking in terms of architecture and design, designed the Demoxen car and the house, and sort of, obviously the sort of the big octagon kind of structures that sort of like tensile strength between three pillars. And he has a series of books, and Operating Manual for Spaceship Earth is like the shortest of the books. And it's awesome because it just resets your framework on like how you think about the world. And particularly I think when it comes to sort of like energy and the energy you put into like in the engineering designs behind it and what's possible. So that's really exciting. I found that inspiring. How I lead my life. So that book I think has been really influential. And I don't know, what was the other question?
Oh, just
a book
like
or a podcast or a...
Oh no, yeah, just like a piece of content that's given you a framework of how you just think about something that resonated and stuck with you.
Yeah, so that one definitely did.
Mm-hmm.
And then also I just think a lot of the things that really stuck with me are like one thing that really stuck with me was The Sound and the Fury by William Faulkner, right? I thought it was like a revolutionary way to like think about language and to think about like narration and like, you know, the narrator's voice and the point of view in such a way. And, you know, likewise, again, back from the literature days, sort of like, you know, I really liked Borges. You know, and Borges again is like really about creating these like full-fledged understanding, like these worlds. You create these worlds and these stories. So I'm always thinking about like storytelling and how do these engineering structures, what is this dynamic system and how does it work together and what kind of story can you tell about that? So those things sort of tend to be inspiring for me. And then music is sort of perpetually inspiring. Mm-hmm. Particular fan of Thelonious Monk when it comes to sort of composition and the approach to the piano. I think the common thing here is like, it's not your average literature. It's not your average song. It's not your average piano playing. It's like, let's break the rules around the conceits that are well trodden in the musical arena and like think about rhythm and how we're going to create melody. And so it's like highly personal, highly original works tend to be very inspiring to me.
I was going to ask favorite piece of British literature, but you kind of addressed that as well.
Yeah.
Borges. What is a commonly held belief about AI that you think is just false?
Oh, a commonly held belief about AI that I think is false. There's so many. I mean, it's interesting. Like, I mean, some of these common beliefs, like AI will take over, or I'll tell you one. I think AI makes you dumb. That's something I've seen like being trotted out on the memes. Like it thinks for you, right? And like you could say the same thing about a calculator, right? Mm-hmm. In terms of like, oh, you're not doing math any day because you have the calculator that has atrophies. I find that totally false. I think AI is an opportunity to like explore something novel or to learn in a way that is tremendously accelerated my ability to like access, learn for any question I tend to be curious about. And so I think on the contrary, it's very stimulating. But you have to learn, like at least at the current phase of things, you have to like to read, right? But I read all day, every day, you know, and like less literature than I used to, more sort of ideas in engineering. But that sort of, I think the ability to have a dialogue with AI and to kind of like, because you think the other way to have a dialogue is like with your inner voice, say, I like to journal, right? Because like you journal is like when you're writing it down and you're thinking about something, it's kind of like you're having a dialogue a little bit, right? Like there's a little bit, there's like a thread, you can kind of pull on it, you can kind of go back to it or whatever. And I think the same thing happens with AI. So when you're exploring, you've got an instant buddy to explore with, right? Who's going to give you a point of view, which may be completely wrong or right, and it's up to you to decide ultimately. But I've heard people say like, oh, well, people that use AI every day, that their brain is atrophying, or like some studies will probably come out saying like people just gave up, just like Google made it really easy for people to search and they just took things at face value. I think the shallower end of the pool can be like that, But if you're really thinking about new ideas and you're trying to explore things, you're trying to learn about new things, and you need some help, having an instant tutor, having an instant frame of reference, having something to edit rather than to generate from scratch yourself is a real boon, like depending on what you're doing, right?
Mm-hmm.
You know, like I think that if you have AI do all your writing's probably not gonna be very good. You know,
Yeah.
but if you're trying to like work out an idea quickly or think about it in a different way or I need a jumping off point, it's like unparalleled, right? I like to have dialogue. I like to have dialogue a lot, and but like that'll wear down your spouse or your friends, right? Like, yeah, you talk all the time. Now I can kind of work it out with like
Talk to the
LLMs.
AI,
I
yeah.
do, and like I get a lot of ideas down, and it's like less working it out, right? There's something about that dialogue and that thread and that continued sort of thread that you're pulling on that allows you to work out and have breakthroughs, I think, at a higher rate than I would otherwise.
Yeah. You know my mug, my Jake mug.
Yeah.
If you had a Scott Wilcox mug, what kind of like few words or phrase would you put on the Scott mug?
Few words or a phrase.
Yeah.
Probably life is for experiences, you know?
That's good,
I
yeah.
think life is like the best parts of life. If you think about like the best, your highest moments, like the best moments, like it all comes down to like a particular experience that you've had, right? Like a moment you've shared with someone at a meal or a sunset or traveling to this unique part of the world or, the visceral feeling of getting a hug, like by someone that you miss, right? Like it really comes down to experiences. And so I very much live my life. And I think the reason why I spent over a quarter of a century working on creating this South by Southwest experience is because I could see the tangible impact it made on people's lives, right? And that coming away inspired from experiences is like the best. That's what's great about a play or a work of art or a piece of music or a meetup you went to or a conference or some sort of trip or unique experience you have. That's what life, like that's how I live my life.
That's awesome. And then last question, what's your favorite nice restaurant in Austin? I feel like a lot of people ask about barbecue and breakfast tacos, but we've got a great food scene. So
Yeah.
always looking for recommendations for nice restaurants.
That's a good one. I say nice. I'd say it's like very approachable, but I like Fukumoto Yakitori.
Yeah.
That place is great because it's a mix of sushi and karage, and you've got like, if you want like a bunch of interesting things to eat without breaking the bank, like you could do the same thing at Uchiko, probably be like 3 times as much,
Yeah.
right? So that's great. I think Fonda San Miguel is a gem.
Oh yeah. Great spot.
And it's got this like old tradition to it. The food is amazing. However, the atmosphere is spectacular.
Yeah.
And I think that that's like a big part of dining. Like a nice meal out should be like everything should be perfect.
Mm-hmm.
Like the chair should be right, the lighting should be right, the music should be right. You should feel taken care of. And that place does a really good job of bringing all those things together. And that's, for me, a nice dining experience is always part of that. Like you could have really great food, but the lighting's terrible and you don't feel comfortable, or you're too hot or you're too cold or it's too loud. You're just not gonna have a good time.
Yeah.
Good
recommendation. I love Fonda San Miguel. I think I've been to Fukumoto Yakitori once, but good recommendations.
Yeah.
Scott, this is kind of the end of the podcast. For anyone that's listening that wants to learn more about what you're doing, keep up to date, etc., get involved with the Janix, like what are kind of the best ways to follow you online or links they should check out? We'll put them all in the description.
Yeah, sure. So Janix.ai, our website's probably like home base for getting involved. You can also find us on LinkedIn, and you can find me on LinkedIn and then on X. And
what's your X handle?
Well, I actually have it under my personal handles for most of my posting. It's at Here and Tomorrow. and you can find it under Scott Wilcox. Mostly, we're doing like LinkedIn and like the web. That's probably the best way.
Awesome. And then what are you kind of excited for over these next 6 months, personally, professionally, et cetera? Like what's kind of top of mind? Are you looking forward to?
Yeah, so top of mind for me is like getting our sort of platform up and running here. We're targeting like a month from now of launching our sort of platform that allows you to spin up private MCP servers really easily. And so that's going to be exciting. And then I think as we get into the fall, really sort of like to be able to see sort of interoperability and sort of like the ease at which people can start to run and operate around agentic systems. I think that's going to be really exciting. What else am I excited about over the coming months? I think I'm just really excited to see sort of like this next generation of AI companies. They're like moving beyond sort of wrap around the foundation model, and I'm really excited for like new platforms that enables more builders, more creative people. I personally find so much joy in like making things and building things that like having sort of world-class tools to do that and having systems to build your own tools to enable yourself, that's always really, really exciting in general.
Awesome. Scott, thank you so much.
Thank you.
This has been awesome.
That's great. Thanks for having me.
Of course.